and they asked me to find IES اللي هو DC current, which is here. Okay, that will place the BJT at the edge of saturation. Okay, so the moment he asks me about DC, this means that I will get rid of C infinity. So high true. Basically, I am studying this circuit here. Okay. هلا, in order to solve for IES, I have first to see what are the voltages that I have. So I'm at edge of saturation. Mafrud, if he gives me the values, it should be this is 0.3, unless he says in the given 0.2, and this is 0.7. بس I'm giving you the gist of it. And at edge of saturation ما بكون فلت بالسات, so بعدني I can still rely on the fact that IC is equal to beta IB. There are two approaches to solve this problem. The first approach is to really assume that IB is finite, يعني البتا منها infinity مثل ما عاطيني هون, بصير بدنا two equations, two unknowns. The reason for that is that I have an equation that relies on this current here, I, and this is I plus IB, and this is IB. And I have another equation that relies also on IC, okay? And IC and IB are related, so basically I will have two unknowns, and finally I can say that IES is equal to IC over alpha, okay? Hello. To solve for this, I have two paths that I need to look at. The path going down, يعني VCC is equal to R times I plus IB plus R times I. And also I have another path, and this path has to be a little bit convoluted. اللي هو إنه الvoltage from here to here is the same as the voltage from here to here, right? And this voltage, I can find it, let me draw here. So if I have VCE is 0.3 and VBE is equal to 0.7, then I can find VCB, right? And if I know VCB from here to here, then I can say that R times IC plus VCB is equal to what? R times I plus IB, right? يعني the delta of the voltage between those 2 points is the same, right? أو بتعملوا KVL loop بهاي كلها minus VCC plus this plus this, okay? هلا this is complex. This is two equations, two unknowns. So we are going to assume that when I want to solve for I will assume that only IB is approximately 0, okay? ساعتها in that point I can simplify my assumptions and say if I approximate this node to be approximately VCC over 2, right? Then I can know what the voltage VE is, right? Then VE will be equal to VB minus 0.7, right? And then I can know what the voltage VC is because VC will be equal to VE plus 0.3 اللي هي فعليا كأني طلعتها من البي يعني. And then I can know that what IC will be equal because it will be VCC minus VC على R. And then I can find IE from IC. So this is the simplified approach. يعني إذا نحله the exact way, we have to really plug into equation to unknown. If you want to solve it the approximate way, then we can solve for IC. Okay, هلا this is DC analysis. Okay, هلا let us now get into the small signal analysis of this circuit. Anybody has any question? طب Okay, so we'll go into the small signal analysis of this circuit. It's a simple circuit. What kind of amplifier? Let's see what happens when the to C infinity when I'm studying the small signal analysis. بدهم يصيروا C infinity بدهم يصيروا كلهم shorted, right? So the C infinity here will all be shorted, and this will also be shorted, and this will be open, it will go away. This is grounded, and this is grounded. So practically here, I have R over 2, right? So I can get rid of this, and this will become R over 2. And so he's asking me, what is the input resistance? What is the input resistance for this circuit? What is the input resistance for this circuit?
Into parallel part.
So it is parallel R pi of the transistor. I have beta, and if I have IES, I can find IC, and I can find IC over VT. So I can find GM, and we know that GM R pi equal beta, so I can find R pi as beta over G. And I can plug it here and find Rn. Okay? Great. Hello. Find the value of the voltage gain. بدو في على Vn. يعني from this point to this point. So this is a simple what? This is a simple common emitter. So it's going to be minus Gm times Ro parallel to R external اللي هي R in this case. Okay, Gm I have it. Ro was it given, or it said, I think if we don't give it, then we assume that it is infinite. So it will be minus Gm times R, right? طيب إذا أجا حدا سألني what is V sig over VO over V sig, pardon me. ساعتها بدي أضرب VO على Vn times Vn على V sig, and Vn على V sig will be what?
Rn over Rn times plus R sig.
صحيح. Okay, so بضربها بهالي quantity that I just found and I move on. حدا عنده سؤال على هيدا البيسك example?
Professor, قطشت شوي when you said about RO and as it's not given, we just assume it's
So
infinite.
here I think in the given, unless otherwise specified, neglect the effect of VA, the channel length modulation in BJTs and MOSFETs in the DC analysis. بس هون ما بعتقد أعطانا RO حتى, so we will assume that it is خلص إنه VA infinity و RO is infinity, right? If you don't see it in the problem, assume it's infinite. Okay.
بس if we have GM, can't we ما فينا نطلع من بتا و GM?
RO R pi هي GM R pi هي بتا. RO هو
R pi صح
VA على IC, right?
Yeah, my bad.
Plus VCE or something. Okay. طيب. So لكن okay. So this is the first problem. Hello. We will look now at the second problem, which is I have a system of poles and zeros, and he's asking me to find the low frequency gain and the asymptotic bode plot, etc., etc. So the first thing that I'm going to do is I'm going to draw the poles and the zeros where they are. So I have pole at 10, 2 zeros, 100,000, and then pole at 10 to the 4 and another pole at 10 to the 5. So حنبلش على 10 عندي P, على 100 عندي Z, على 10 to the 3 I have another Z, then 10 to the 4, then 10 to the 5, and it's another pole. And the first question that he asked me is, what is the low frequency gain in dB? نحط ال S equals 0, this will give me 100 volt per volt. ناخد له 20 log base 10 لل 100, and this tells me that I have 40 dBs. Okay. طيب بيجي بيقول لي find the approximate gain of the amplifier at 330 radian per second. So 330 is somewhere between 100 and 1000, so it's somewhere here. So let's see how the curve looks like. I will start from 40 dBs, right? I will drop by 20 dB per decade. هأوصل لل 20. Then I will hit a 0 and I will be flat. So هاي فيها typo. هاي it should be لكانت sorry هاي محطوطة مش عفوا. Okay. So okay. So this is 20 dBs, right? هيدي بالdB هون. So at 330 I'm at 20 dBs يعني 20 log A هو 20. This means that log A equals 1 يعني A is equal to 10 volts per volt. اللي هي هيدا الأنسر. Okay. So this is the answer that you are looking for. Okay. Clear? طيب بيجي بيقول لي the approximate gain at omega equal 5 mega radians per second. هات لنشوف. بده على 5 10 to the 6 يعني. So this is going to be somewhere here. Okay, so this is going to be here 5 10 to the 6. Okay, so let's see how the graph is going to behave. So I hit another 0, I go up plus 20 dBs per decade. برجع I hit a pole, I'm going to flatten and plus 20 minus 20 بتصير 0. Is that correct? هيدي لحظة بس أنا أحسبها. So هون minus 20 هون صارت 0 هون صارت plus 20 هون رجعت صارت 0 هون it's going to go down, right? At a slope of minus 20 dBs per decade. Please correct me if I missed something. Okay. So لكينا إذا بنحسبها since these are all steps of 10 in the frequency يعني I'm losing 20, I'm remaining fixed, I'm gaining 20, I'm remaining constant. Up till here I came back to 40 dBs, right? So from 10 to the 5 to 5 10 to the 6, all I can say is that gain 2 is equal to gain 1 minus 20 log, right? And هيدا slope minus 20 omega 2 over omega 1, where omega 2 is 5 10 to the 6, right? And omega 1 is really the 10 to the 5, okay? And gain 1 is the 40 dBs. Is that correct? Okay. طيب. هلا last question in this problem, he is asking me to, in the last question, he's asking me to find the phase angle at very high frequency. Okay, so when omega tends to infinity, okay, the poles are going to give me minus 90 degrees, and the 0, depending on its sign, will give me plus or minus 90 degrees. In this problem, I have 3 poles plus 2 positive zeros. So, and this is going 3 times minus 90 plus 2 ضرب 90, and this will be minus 90 degrees. Okay? So this should be simple for you. So لكن هلا we're gonna move now to the next problem, which has some complexity towards the end, but I'll try to solve it in a simple fashion, which will give us an approximate answer. And let us look at this circuit. So here I have a current mirror. Okay, they're telling me that the voltage at the gates is 1 volt. So this is designed to give me 1 volt here. I have W by L1 equal W by L2 equal to 9. So those two I have their W by L. Okay, and I have K prime and VT and lambda. And VDD is 3 volt. And then he's telling me first find the value of R in kilo ohm. So ما جاب لي سيرة RX. He's just asking me to look at R. So automatically I know, since I know the voltage, I know VT, I know K and prime, and I know that this should be in saturation, I can solve for R from this path. Okay, so I can start by stating that IR is equal to IM1, and this is VDD minus 1. Okay, over R is equal to half K prime W by L times VGS minus VT all squared. I have all quantities, I find R. Okay. Then he tells me, now I'm gonna look at the output node. And at the output node, he's asking me in the first question, assume that Rx is 0. So he's telling me let Rx equal to 0 and let VO equal VDD. So let me assume that this node now is VDD, so this is 3 volts, and that this does not exist, it's shorted here. Okay, and he's saying find the output current. How do we find the output current for this problem? Is it complex?
We have everything, no?
Exactly. So we have VD, so all I have to say is that have K prime W by L times VGS, I have it minus VT all squared into 1 plus lambda times VDS. Okay, I have VDS لأنه هيدي grounded خلصت القصة. Okay. Then in the last question, he's asking us now to consider Rx again. So we're considering Rx now, and with Rx, he's saying that when Rx, which is much smaller than RO2, oh, pardon me, sorry. Rx is much smaller than RO2. Sorry, okay. So عم بلش يخبرني إنه Rx أصغر من RO2. When it is inserted here at this node, okay, the output resistance RO increases by a factor of 4.5 times. يعني هي ال RO لما ال Rx equal 0 شو بتطلع؟ إذا ما في Rx، إذا هاي 0 أنا عم طلع من هون حشوف ال little RO2 صح؟ And then when RO لما ال Rx different from 0 in the presence of Rx، RO حتكون هي ال RXY صح؟ So حتكون GM times Rx times RO2 plus RO2 plus Rx. صحيح؟ Right, لأنه looking into the drain of a transistor هيدي DC بايس بنعدها بالcurrent mirror وهيدي grounded with a resistor RS at the source حيكون عندي هو GM RO RS plus RS plus little r. Okay. طيب so هو عم بيقول لي إنه هيدا الريزستنس الجديد على الريزستنس القديم حيكون increased by a factor of 4.5x. يعني GM RX RO2 plus RO2 plus RX على RO2 هي حتطلع 4.5. Okay. But he's telling me that Rx is much smaller than RO2. Okay. So either I would say, well, I can get rid of this. Okay. And then in this scenario, I will have 1 plus GMRX times RO2 على RO2 بالdenominator بتكنسل is equal to 4.5. Okay. Or هلا نشوف شو approximation فينا ناخذ. Now he's saying we have this relation, and then he's asking us in a twist to estimate the value of VOV for the MOSFET M2 after inserting the resistor RX. طيب هلا نحن بنعرف ال VOV شو بتساوي ال VOV؟ احنا نعرف عنا relation إنه GM هي 2ID على VOV, right? So basically we know that ID is equal to what? GM ضرب VOV على 2. Okay, so خليها relation بين GM وال VOV. But at the same time I know إن ال current ID هو قاطع بهالريزستور, صح? Okay. So if this is node S, what is VS?
ID RX.
ID ضرب RX. طيب. What is also VGS? It is 1 minus VS, right? صار عندي VGS هي 1 minus ID ضرب RX. و VGS minus VT شو بتساوي؟ نشيل هاي. What is VOV?
VGS minus VT.
صح, VOV هي VGS minus VT يلي هي 1 minus VS minus VT. صح, يلي هي 1 minus ID ضرب RX minus VT is equal to VOV. طيب ما أنا عندي ID كمان function of VOV, صح? صار I'm gonna put star in this equation here and let me write it now in another color. let me نكتبه هيدا. Okay, so شو صار عنا هون هلا؟ صار عندي VOV is equal to 1 minus GM VOV GM RX, صح؟ times what? GM RX, sorry, times VOV over 2. مظبوطة هاي؟ حطينا ال ID هون، خدت محل ID GM VOV over 2. GM VOV over 2 ضربتها ب RX. اوكي, وماينس VT. طيب فيني جمع ال VOV على ميلي والباقي الفاريبلز على ميلي؟ يصير عندي 1 minus VT, صح؟ is equal to VOV into 1 plus GM ضرب RX على 2, صح؟ Okay, and I have GMRX what it is equal to, so I can plug it in and find the value for VOV. Okay, هلا it's a little bit convoluted question, but what really matters in all of this, okay, is that you know two things matter here. Those two things that matter إنه هو عطاني هيدا الفولتج، إنه أنا I know how to represent VOV بتصير dependent على هول two nodes لما يكون في عندي resistor. So it is really VOV is really equal to 1 minus VS minus VT. Okay, وال VS هو I times IO فعليا times ال RX. Okay, and IO I can express it as function of GM and VOV. يعني هاي relation مهمة نحنا نعرفها. اوكي, حدا عنده سؤال؟
Yeah, سؤال بروفيسور.
مم.
إذا قالوا لنا إنه مثلا RX is not much smaller than RO2, إنه they just gave us RX source resistance يعني. هاي كلها إنه
هلا they
كتير
have to tell us
RX.
something. إذا كانوا قد بعضهم فينا نحن يمكن نجي نقول إنه GM RX RO أكبر من هو. So cancel هو بيبقى عندي هيدا الترم مع هيدا الترم. يعني I have to give you some assumption to make it work.
Yeah.
Sorry. وإلا ما بتزبط يعني.
Yeah.
Okay. Okay, great. طيب. يعني بس هو المهم هون انه تنتبهوا لهي الريليشن. هيدي هي الفي جي اس هون تطلع الفي او في، والاس نود هي ديبندنت على الكرنت القاطع بالار اكس. اوكي طيب هلا now he's moving into the amplifier يعني modes. So this circuit is a common source with source resistance. Okay, so this is a CS with source resistance. And for this circuit, he gave me GN, RO, RG, I have it, RD also, and I know that RD is equal to RL. So هاتنين قد بعضهم وعطاني ال RS is 1K. So I have all of these and I have the GN and RO. So this is a straightforward application of the equations of the sheets that we studied before. Okay, هلا for this circuit he starts by asking what is the input resistance. Does it matter if I have RS or not? شو الكرنت اللي هون؟ 0. So خلاص دغري it is equal to RG. Right? So it's equal to RG equal 1K. هلا find the output resistance RO in kilo ohm. So عم يرجع يطلب مني طلع ال RO. هلا هيدا ال RO لأنه هو رسم لي وين. Okay, and RD is not the load. Typically the output resistance ما بنحسب ال R load. بس نحن حنجي هيدي is gonna send current up and down. طبعا هيدي is grounded in small signal. And Vn is going to be set to 0. So it's exactly looking into the drain with the gate grounded. And I have resistance here, and then I have a resistance here. This is the ground. So looking from here down, I will see RXY in parallel with RD. And this RXY below is RO plus RS plus GM RO RS. Okay. So هيدا هو ال output resistance لهيدا السيركت. هلا بيجي بيقول لي find the gain. Okay. هلا بما انه انا I have the RO and the GM صارت equation هي ال convoluted equation تاعت ال common source with source resistance يلي هي this big one. Okay, so I'm going to take all of this. The only difference here is that in my circuit, what is RD? RD is the total resistance that I see at the drain node, and RS is the total resistance that I see outside my transistor at the source node. يعني أنا if I want to come back to this image here and check it, I need to see what would be the effective RD. هيك لنعمل erase هون. Yeah. So let us see what is the effective RD for this circuit here. And now I have my input and I want from the input node to the output node. RD represents the effective resistance seen at D outside the transistor. So this will be RD parallel to RL فعليا. Right? يعني هاي فيني شيلها بس فيني أقول إنه أنا عندي هاي النود RD parallel ل RL و RS ما في غيرها. So I will plug into the equation which will be now minus GM RD parallel ل RL over the rest of the equation اللي هي 1 plus GM RS. So plus we have an expression which is RS plus RD parallel ل RL over R. Okay, that's the only difference between this and the sheet. بس كلكم are comfortable while you have RD parallel ل RL, right? طيب, okay. So هيدي it is simple for us. Now he's saying in this part I'm gonna assume that RO is very large, صارت infinity. And that I have a capacitor that is connected from the output node to ground. And it determines the 3 dB frequency. All others are negligible. عم بقول لي find FH in megahertz. هيك لنشوف. If we have now, we put a capacitor at the output node. Okay. So إذا حطينا الكاباسيتور هون على الأوتبوت and the ground. Okay. It's going to say I have to set Vn to 0 automatically لأنه عندي signal جاي من هون. I'm going to see what resistance this capacitor will see. So this capacitor is going to see this plus this in parallel with this، لأن إذا بعد current أصلا منه حينزل هون، صح؟ يعني if it sends a current, part of the current will flow into the resistor, part will go up and part will go down. أوكي؟ طيب great. هيدي هي ال RO اللي نحن طلعناها. So RD parallel to this is RO. Therefore it will see RO parallel ل RL. صح؟ يعني the capacitor will see RO parallel ل RL and it will see RO parallel ل RO parallel ل RL and it will, the frequency will be 1 over RO parallel RL times C. طبعا إذا بدي إياها بالميجا هرتز I need to divide by 2 pi and divide by the proper units. أتأكد إنه اليونتس بيعطوني ميجا هرتز. أوكي؟ حدا عنده سؤال؟ طيب great. So this was straightforward. لكن هلا let us see the next question. Now he puts a capacitor CGD. Okay, CGD وبيقول إنه عندي ال input is coming from a signal source. Let us see what's the given that he has changed now. And in the given, it tells me that assume that RS is 0. So صفرنا ال RS صارت grounded. Okay, خلينا نرد السيركت مثل ما كان. Okay, so now I have Vn بعد هون. And also he says assume that the Vn comes from a signal source, the sig having an internal resistance R sig equal Rg. شو يعني؟ يعني automatically قال لي هي ال Vn جاي من R sig هي بتساوي Rg وعند V sig عندها هيدي ال R sig. So this is V6. صار هيك circuit. Okay. And then he says, well, find the OCTC resistance seen by CGD. So بدينا نلاقي resistance seen by CGD. يعني أنا إذا عندي هون capacitor يلي هو CGD. Okay, he wants me to find the effective resistance seen by this. Automatically, if I want to find the resistance seen by CGD, شو بعمل بالsignal sources؟ هيدي grounded لأنها small signal. هيدي it will go down to what? To 0. I will short V-sig. Okay. صار عنا the traditional example of a common source amplifier. هيدول الاثنين فين يكونوا in parallel RD parallel ل RL. Okay. وهيدي is grounded النود وهون على هاي النود شو عندي؟ عندي resistance. قد ايه effective resistance هيدي على هاي النود هو؟ عندي بين هاي وground RG وبين هاي وground تحت RG. So this is RG over 2. Okay. And now I have this capacitor sitting here between those two nodes. Okay. If you recollect from the pi model اللي درسناه لما درسنا ال current source قلنا إنه بس ال capacitor CGD إذا هو sitting بين ال gate و drain of the transistor and when there is a resistor بينه وبين ال ground من جهة ال gate, what is going to happen here إنه حيصير في عندي هون RG over 2. أوكي هون ال capacitor قاعد بين هون 2 nodes وهون عندي GM VGS. right وعندنا هون RO وبارلل كمان لمين؟ للRD parallel لRL. right. So in this scenario, if I put a supply in place of the capacitor to find the effective resistance, اتفقنا إنه the effective resistance seen looking into this, okay, is what? هيدي هي GM VGS. هيدي هون هي
It's like RXY.
Exactly. So this would be RXY يلي هو حيكون RG over 2 plus RO parallel ل RD parallel ل RL plus GM ضرب 2. ممكن ضرب هيدا وهيدا. Okay. So plus GM RX RY يعني ال RX هي هاي وال RY هو ال parallel لهول 2. Okay. So this is what we find for CGD. وهي تقريبا the only case that we that we deal with the transistor being RXY. يعني بدها تكون هيدي بين هاي النود والجراوند عندي resistor، ومن هون واضح شو هو resistance seen looking down and the resistance looking up. حدا عنده سؤال؟
مس أنا عندي سؤال.
مم.
بس for the question اللي قبله, did you say إن the resistor seen is RO parallel ل RL or RD parallel ل RL؟
Okay, so for the previous question
يعني 14.
خليني أرجع أرسمها لل14.
لأنه they said إنه RO is very large, so I don't think فينا ناخد
RO اللي هو
R out.
معك حق RO with RO tending to infinity. صح. Let me repeat it. I rushed through it. هيدي correct. هيدي وضحت RXY.
Yes.
Okay, so let me erase all of these. It'll take a second, and let me talk about the previous problem اللي هو لما كنا عم ناخد من ال VN عند الكاباسيتور جاي على ال output. اوكي بس قالوا لنا RO is very large، so حنبلشها من scratch لأنه RO is very large. And in this scenario, if I have a capacitor sitting here, okay, so this is a capacitor sitting here, and I will set Vn to 0 طبعا, and I'm going to see what the capacitor sees. So it will look in here and up here and then down here, but this branch looking down يعني هيدا اللي سميته R star بهالحالة لأن هو R effective حيكون ب RD parallel ل RL parallel ل R star صح؟ But R star will be looking down the transistor for RXY with RO tending to infinity. هلا هي RO plus RS plus GM RO RS. When RO tend to infinity, R star is going to tend to infinity. Okay, and accordingly هتصير بس RD parallel ل RL. Okay, thank you Liam. حدا عنده سؤال؟ Okay, great. طب so لكن هيدا الكويشن بنكون قطعنا. هلا if إذا حدا عنده سؤال وقفني يعني. اوكي طيب هلا عنا اعطونا نيو سيركت وقالوا لنا انه بهالسيركت في عنا مانيفاكتشرينج ايرور وانه كان اصلا يعملوا كاسكود امبليفاير يعني يكون الانبوت من هون بس بالغلط انطبع الانبوت من هون. صارت الانبوت سيجنال عم تجي على هي النود والاوتبوت عم ينقاس من هيدي النود and all the G values هن DC biases. اوكي طيب عم يجي يخبرنا يسألني قال لي you know GMRO it's equal to 50 and now he's saying well let us compare the gain and the input resistance to that of a regular cascode. هات لنشوف هيدا what type of amplifier is this. الانبوت من السورس والاوتبوت من الدرين ل Q2 فعليا والبقايا هن هيدي لود وهيدي لود على السورس نود. شو هيدا الامبليفاير common gate. Okay, so do I expect that the gain of the common gate will be like the gain of the cascode? أنا شو طيرت علي بالكاسكود؟ بالكاسكود منين كنا نحط الانبوت؟ من هون يطلع الاوتبوت وين؟ هون. يعني أنا I already by making this the input here I have skipped what? I skipped one stage. وصلت من هون لهون صح؟ So بدل ما أكون common source plus common gate لأعطي كاسكود صحيح؟ بس خليت عندي ال common gate. Okay? فإذا I expect that the gain is going to be what? Smaller. صح؟ Okay. طيب the second question, what about the input resistance؟ شو قصته الانبوت ريزيستنس؟ لو كان الانبوت لإلي مثل الكاسكود، بحالة الكاسكود كان حيكون الانبوت من هون، هيدا شو هو؟ infinite versus بحالة إنه الانبوت انحط هون هلا لل new faulty amplifier, the input is looking here, so it's going to look up and down, right? So هيدي finite لأنه تحت RO فوق عم بطلع بترانزستور parallel to something, it's definitely at least RO, so it's definitely finite. صح؟ So وحتى اللي فوق هيدي 1 على GM عادة بتكون صح؟ So أكيد نزلت عن الانفينيتي. So for sure it's smaller. Okay. طب هلا بيجي بيقول لي find the gain of this amplifier. بروح دغري أنا عند ال circuit for the gain of the common gate يلي هو هون. بتطلع عليه بيقول لي إنه if you have the input at this node and the output at this node, find for me all the effective resistance beyond the output node outside my transistor إذا عملت عليه circuit. وfind for me كمان outside the transistor at the source all RS. بس أنا I don't need it. It will not show in my equation. So هيدي I don't care for it. I don't need to find it to find the gain. بس هاي yes, it's going to show into my equation and it's GM plus 1 على RO ضرب RD parallel ل RO. Okay? So لكن بدي RD و let's see what we will find. So let's come back to the problem and let us see how we calculate those quantities. Okay? So خلينا نشوف لكينا شو ال effective resistance RS ما بدي إياها ما بتفرق معي. So أنا هيدا هلا حأرسمه effectively. This is the transistor that I care for. Okay, so هيدي grounded, هيدي VN جاي من هون مع some RS وهيدي من هون ورايح عندي RD. طيب هيدي ال RD it is the resistance looking up from here into what? Into the drain. هيدي source هيدي drain صح؟ لأنه هيدي PMOS transistor. So looking into the drain وهيدي كمان drain source لأنه هو PMOS محل الأرو هو source. So هاي is exactly equivalent to what we have learned before للفيرجن الثانية لأنه هيدي هون هو حيصيروا grounded نحن عنا صح وهيدي grounded. So it's exactly equivalent to looking down the drain بحالة الأنموس لهو two transistors. أوكي هيدا القريب لإلي حسميه 3 واللي بعيد عني اللي أقرب للجراوند حسميه 4. Okay, and in this scenario, the effective resistance seen will be RO3 plus RO4 plus GM3 RO3 RO4. هلا هني هون ال R's قد بعضهم عاطين ال GM RO معتبرهم كلهم identical. Okay, all the transistors have the same GM and RO. يعني هاي حتطلع هي GM RO squared plus 2RO. Okay, هذا ال effective resistance اللي حنشوفه عندي. اوكي طيب great. what is the gain؟ هيك لنشوف شو الجين اللي حيطلع عندي. الجين هو if I look at the sheet 1 second I will look at it from the other window. The effective gain is هو GN plus 1 على RO into RD parallel ل R. okay هلا we can approximate this to be GMRO squared. اوكي ساعتها RD parallel ل RO حتكون هي 1 على GMRO squared plus 1 على RO كلها سوا inverted. اوكي وهيدي هي GM plus 1 على RO. Let's see how we can reduce this. So this is really 1 plus GMRO على RO, right? ضربنا هاي صلنا عليها. And this will be إذا ضربت يعني بدي أضرب هاي بالجي ام ار او هاي الجهة لتصير هيدا الدينومينيتور هو ذاته حيصير عندي GMRO squared وهون عندي 1 plus GMRO inverted حيصير عندي 1 plus GMRO على RO ضرب GMRO squared على شو هاي 1 second over 1 plus GMRO. Okay, does it come out to be 50? Yes. Okay, so هاي وهاي بيكنسلوا وهاي بيكنسلوا بيبقى عندي GMRO بيطلع ال overall gain اللي هو already عاطيني إياه إنه equal ل 50. Okay, so this is how you handle. يعني أول شي بتطلعوا الإكسبريشن لهيدي بترجعوا you plug it in into RD and you reduce it as function of GMRO. Clear؟ حدا عنده سؤال؟ طيب أوكي.
All clear.
Okay, thank you. هلا بيرجع بيجي بيقول لي find the input resistance of the defective amplifier. Okay. So للinput resistance للdefective amplifier I'm going to set طبعا كل ال DC biases grounded and okay and here this is my transistor, so the transistor is going to look at from Vn and it's going to look up and down. Okay, خلينا نحطه بغير colors. It's going to look up and down. طيب هاي حنسميها R star. هيدي هي RO صح؟ So it will be RO parallel to R star. هلا R star هي فعليا looking into the لما نعمل input resistance يعني هيدي كمان grounded pardon me. R star it's looking into the source node of a transistor with resistance here RD واتفقنا نحن انه هيدي هي تقريبا GMRO squared right يعني من هون ورايح على الدرين وطلوع عند GMRO squared. طيب I'm looking into this transistor. هيدي الفورمولا بدي ارجع اجي على الريزستور sheet okay where I look from the source node. okay so بتطلع RD plus RO على 1 plus GMRO. okay so let's go back and it will be RD plus RO على 1 plus GMRO and so it is going to be RD is GMRO squared RD plus RO على 1 plus GMRO. طب هاي simple لأنه I can cancel I can factor out RO صح؟ وتصير 1 plus GMRO على 1 plus GMRO بيروحوا هون. so ال R star هي RO لكن ال Rn هي RO parallel ل R star which is equal to RO over 2 تقريبا. okay هلا هون طالعة معه 0.51 RO so I think he did not assume this as GMRO squared. He assumed it is GMRO squared plus 2RO أو شيء هيك يعني دخل الكفة الأبروكسيميت ما أخذ approximation. okay so إذا جمعنا plus 2RO بيصير في عندي some ratio some factored ratio into this. okay طيب so clear بس البيسك concept واضح يعني ليش طلعنا فيها من هون up into R star وهي من هون أنا بعرف كيف طلع looking from the source إذا بعرف هو شو هن وهو بعرف شو ال effective resistance لألون. okay and it's in parallel with the resistance looking down which is RO. حدا عنده سؤال? anybody has any question? طيب okay طيب so I will assume that it is clear hopefully. okay هلا هيدا going to be slow and ما رح أتراجع اليوم. Okay, so for the amplifier circuit shown in figure 5, the supply voltage is VCC. Okay, and 12, and the resistor values are R1 equal to 20. أعطاني R1, أعطاني R2, and he gave me also R3. I have them. RC I have it, and RE I also have it, and RSIG I have it. Okay. And then he's saying C infinity are very large and can be considered short مثل ما اتفقنا على frequency of interest, and the bipolar transistors have very large beta. مجرد ما يقول very large beta يعني this means that IB is 0. Okay, and R pi tends to infinity. يعني إذا beta is large, this means that R pi tends to infinity وال IB هي 0. يعني فينا عملهم مثل المصفت. So we have C pi equal 1 and C mu equal 2 picofarad. Find the DC current flowing in resistor R1. So مجرد ما عم يسألني عن DC, I need to remove the C infinity, right? And now I have a long stretch where I have R1. This is VCC. هيدا الكرنت 1 is 0. Okay, بكفي عندي R2. هيدا الكرنت فايت على BJT is 0. And then I have R3 and I have all of their values. I have VCC. Can I find the current that is flowing in R1? Yes, لأنه هو ذاته الكرنت مكفي من ال VCC نزول مش عم يقسم هون زيرو الكرنت رايح هيك so مكفي هو ذاته وهون رايح current zero. We have current 0 so it continues all the way down. Okay, so it is VCC over the sum of the currents. I believe so. Okay, so now again he is asking us about the and let me just double check. Yes, okay, now he's asking me about the current, about VCE. So he wants to find VCE 2. So let me erase this and let us look for VCE 2. If he wants to find VCE 2, which is the voltage across this here. So VCE 2 is here. What is it? Okay. And for me to know this, he already gave me some hint, okay, about finding the current that is طبعا هو حيروحوا بالDC analysis هو بيروحوا هيدا is open. I found the current that is flowing in these. Okay, so do I know what is the first the voltage at the base of each one of these nodes? Can I know the voltage at the base of each one of these nodes? Through what I can know it? Through voltage divider. So بقدر أعرف VB2, VB1. Okay, I know VB2, I know VB1, I know that this is on, so I know that this is 0.7 and I know that this is 0.7. So can I know what's the voltage VE? إذا بعرف هاي بقدر أعرف يعني I can know that VB1 is equal to R3 times I, where I is this current, if we want to simplify matters for us, or by voltage division. And therefore I can find that VE1 is equal to what? VB1 is VE1 is equal to VB1 minus 0.7. So this means that I can find what IE is equal to, right? Is equal to VE1 over RE, right? Okay. Now I find this. What can I also find? إذا أنا عم بقول لي هو إنه البتا tend to infinity. If beta tends to infinity, what does this mean? That IB equal to 0 and IC is equal to what? To IE, right? So I know the current that is flowing in this branch now. Okay. Do I have RE? Do I have RE given? Sorry. عندي ال RE. Okay. So now I can know the current that is flowing here. So I can find what? I can find VC2, right? So I can find VC2. صح؟ يعني معي IC IQ2 equal IQ1 لأنه beta is infinity and it's equal to IE. صح؟ ما بقى أعطلها. So I can find VC2 اللي هي VCC minus RC times IC صح؟ بيفضل بدي أعرف VE right? Can I find VE from VB2? And VE2 is equal to VB2 minus 0.7 volts. يعني إذا بدنا نلحق steps يلي قطع فيهم بهيدي السيركت okay the steps were as follows هيك نرجع نعيدهم بس last time okay so first we can find so first أول شي طلعنا ال VB2 and VB1 by voltage division okay تاني شي طلع لي VE2 and VE1 فينا نطلع VE2 and VE1 as VB2 minus 0.7 and VB1 minus 0.7 صار معي whole voltages from VE1 I can find I E اللي هي IC for both transistors and IE is equal to VE1 على RE okay and then this is the third step and then the fourth step I can find VC2 is equal to VCC minus RC times IC okay so صار فينا إذا طلع VCE2 okay واضحة right okay طيب great هلا هيدي as far as the DC analysis is concerned. Now we're going to erase all of this and we're going to jump into the question اللي المفروض يبلشوا يحكوا هلا عن hopefully small signal analysis, okay? So let's see now what happens in small signal. If somebody knows how to erase much faster, let me see if I have it object eraser, okay. Okay, so let us see now how we handle the remaining questions. Okay. So the next question that he asks us is find the small signal gain VO over Vn. The input Vn is the signal at the base of Q1. So بلش عم بيقول لي إنه طلعي على البيس of Q1 طلعي لي VO على Vn. So here is Vn لأنه طبعا هيدي will be shorted, هيدي will be shorted, this will be grounded. And now Vn عطول بترجع على آخر ال Vsig. طيب هلا هيدي صارت shorted. What do I have now? Let's see how and this is becomes a ground and this is becomes a ground. Let us see if we can simplify how the circuit looks like and this becomes shorted. So practically speaking, I have transistor Q1. Okay, صار عنده ground هون لأنه هيدي النود is shorted. And I'm going to try to connect the remaining elements. So R3 is still between هيدي النود والground. Okay, R2 حطلي ground هون هو بين هيدي النود والground. So this is parallel to R2. And then R1 راح صار بين ground وground بطل مبين عنا. Okay. Now he's saying that Vn is this node, so I don't need to worry about Vsig. And then on top of this transistor here, I have another BJT whose base is grounded. لأن هاي النود صارت 0 ground. وعندنا هون a resistor RC and this is VO that is being measured here. Okay, so هيدا الgain, it is really, now if we look at it, it is a two-stage gain لأنه on the path between Vin and Vout, I have an intermediate node حسميها VO1. Okay, so هيدا صار هو common base, common عفوا emitter. So this first stage is a common emitter and the second stage is a common base. Okay, and now if we want to find the gain, so then I will have to set the gain to be equal to VO over VO1 times VO1 over VN. Okay. So let us, let me see if I can draw it on a blank page. Okay, so I will take this to another sheet بس حتى نكون مرتاحين فيها. So practically speaking, we ended up with a transistor, right, with this grounded. Here I have some resistance. This node is my Vn. Then this is VO1. Then I have a common base stage. And here I have RO, VO عفوا, and this is RC. Okay. So for VO1 over Vn, it is the gain of a هيدا Q1 حنسميه هيدا اللور هو Q1 صح وهيدا Q2. So here we will call this VO1 على Vn equal to the gain for Q1 with some effective resistance here RD. Okay, and this is node VO1 and this is Vn. The effective resistance RD is really all the resistance looking up, okay, into this stage. So I need to model RD, which is here, هيدا ال RD. هي فعليا it is the resistance looking up into the emitter of a transistor with effective resistance RC. Pardon me ما بقى ترسمها هون. بس looking up from here. هلا هاي إلها rule بالBJT, so we can plug it in, right? And if we go to the sheet of the BJT, the rule is going to be هي rule of the BJT, which is looking up the emitter, and it is going to be R pi parallel to RC plus RO over 1 plus GM RO. هلا هيدا عطاني beta is very large, right? So if beta tends to infinity, then in this scenario, let me just double check, very large beta, يعني R pi tend to infinity راحت, so it will be RC plus RO على 1 plus GM RO. Okay, so it will be RC plus RO over 1 plus GM RO. Now, I don't know even if he gave us RO. Let me reread the given. So in this problem, he said the bipolar have large beta, and he did not mention RO. So in this scenario, if RO is very large, okay. Now, if RO also tends to infinity, بصير هيدا كله 1 على GM. Right? لأن هيدي راحت, and here we have RO over 1 plus GM يعني على GM RO. These are negligible terms. Okay, so I can now find what is the effective resistance for me. So here I see 1 over GN. Okay, and therefore, and the gain, since RO is infinite, the gain is typically minus GN times RO parallel RD, بس ال RD هي RO is infinite, so RO parallel RD, and this is minus GM times ماشي 1 على GM, so بتطلع إذا كنا عم نحسبها صح هيدي 1. Okay, and I'll double check it for you. Okay, so هيدي this is minus 1, right? Okay, so this is minus 1. This is for the common emitter stage. هيدي هي لل VO1 over Vn. Okay. Now I need to calculate the gain for what? For VO over VO1. So now I need to look at VO over VO1. Okay, and in this scenario, the circuit really looks like this, and the input is at this node, and the output is here with a resistor RC available here, and this is VO1. خلينا نرسمها مظبوطة. Okay, So this is the resistance here, and this is RC, and this is VO. Okay, and this is VO. Sorry, pardon me, VO, هيدي VO. طيب, the equation for this from the sheet, for the voltage gain sheet, automatically هي حاخدها أنا من ال case where we will have the common base. Okay, اللي كنا عندها من شوي. بس it is going to be GM plus 1 على RO ضرب RD parallel ل RO. Okay, so here I don't really care for RS. So GM plus 1 over RO. RO قلنا هي infinite. So technically this will go away and parallel ل RO حتصير GM RD. Okay, so it will be GM whatever resistance I have here. So then I will end up with GM plus 1 over RO into RD parallel RO from the voltage sheet. If RO tends to infinity, this will go away and this will go away. So تصير عنا إياها هي GM times RC لأنه RD هي RC عنا إياها هون. Okay, so بصير عنا الجين هو minus 1 times GM times RC. Okay, therefore VO over Vn becomes equal to minus 1 times GM times RC. Okay, now if GM is not given and I know what the current is, okay, then I can use the current to find IC over VT, okay, and then find the GM. Okay, and the GM is nothing but IC over VT for this example. Okay, حدا عنده سؤال؟ طيب. Okay, great. هلا we will now look into the input resistance of the circuit. So خلينا نرجع على الأسئلة. So in the question sheet, sorry, they're asking me about the input resistance of this circuit. So بدهم مني input resistance. So خلينا نحي هون نطلع what is the input resistance. حدا can guess what is the input resistance?
R3 parallel R2.
Exactly. ليش؟ لأن الكرنت شو بيساوي بال beta is very large.
Yes, IB equals 0.
Exactly. So R beta tend to infinity. So R pi tend to infinity. يعني ال Rn مثل ما اتفقنا نحن إن this is going to have R3 parallel to R2 circuit, and the rest of the circuit is going to be connected up. So looking in here, we are going to see R3 parallel to R2. Okay? Okay. طيب حسب ما شرحنا قبل. هلا بيرجع بيقول لي now in after applying Miller approximation to CMU1 by assuming that VC1 over VB1 is equal to minus 1. So let me draw on the other sheet the circuit. So he is telling me now حنرجع نرسم نحن small signal model. اتفقنا إنه عندنا Q1 it is grounded لأنه عمل shorting C infinity. هون عندي R3 parallel ل R2 عندنا ال R6 وال V6. Okay, and we have here the other BJT which is really grounded, and then it had RC. Okay, this is VO1, and he's telling me now apply Miller first to capacitor CMU2 by assuming that VC1 over VB1 is equal to minus 1. So عطاني الجين هيدي هي Q1 وهيدي هي Q2, and he gave me the gain for بس أتأكد لكم منها لل VC1 على VB1. Yeah, opening another clearer picture. Okay. Okay. So VC1 is for Q1 هيدي, and this is VB1. So this is C1 and this is V1. And he said that we have given VC1 over VB1 equals -1. And he's saying, look at CMU2. Let's CMU1, often apply mirror to C. Where does CMU1 sit? CMU1 sits here. Then the base will collector like Q1. So what happens when I apply mirror to it? هتنزل two pieces. One piece which will be at the gate البيز عفوا هيكون عندي هون C1 وهون تاني بيس حتنزل بين هيدي النود والجراوند C1 هي C2 أو شو نسميها C01 C02 أوكي حتصير 2 capacitors. طيب C01 هو CMU1 times 1 minus K اللي هي CMU1 at 1 minus 1 هي حتصير 2 و C02 هي CMU1 into 1 minus 1 over K اللي هي CMU1 into 1 minus 1 كمان لأنه K equal minus 1 حتصير 2. So هيدي هون حيكون عندي 2 CMU1 وهيدي هون حيطلع عندي سائب 2 CMU1. Okay, and now I need to find the, after I break this by Miller, I need to answer the questions. Find the total capacitance between the collector of Q1 and the ground. هلا هو قبل كان عطينا given, he told us that we have given, which is C pi for all the transistors. So okay, with the given كمان عطانا إنه C pi is equal to 1 picofarad and C mu is equal to 2 picofarads. Okay, طيب. Now if I want to place all the other capacitors هيدا عنده C mu 2 هون بين البيس والcollector وعنده بين البيس والemitter C pi 2 صحيح وهيدا عنده هون على هيدي النود عنده على هيدي النود على هيدي النود sorry pardon me for the noise عندنا هون C pi 1 اللي هي بين البيس والجراوند وكان عندنا C mu 2 1 اللي فرقناها هون كان عندي هيدا وأنا هلأ شلته okay between those two nodes. طيب so what is the total capacitance at this node after I applied Miller to C mu 1 صار عندي من breaking it the value to CMU1 and also between this node and the ground هذه بين this node and the ground شو عندي كمان من هاي الجهة I can see C pi 2 لأن هاي فيني شيلها أنا أوكي وفيني ننزل C pi 2 automatically to become parallel to it so I can put C pi 2 here. Okay, therefore I have 2 times C mu1 so 2 times C mu1 اللي هي 2 plus 1 اللي حتطلع 5 picofarad هيدي جاية من هون وهي جاية من هون. Okay, so لقينا له total capacitance that is available at the node. هلا برجع بقلنا find the OCTC resistance. Find the OCTC resistance seen by the capacitor Cx from the previous question. Cx is between the collector of Q1 and the ground. يعني عم بقول لي طلعي لي total resistance seen by this capacitor اللي قاعد هون. So I'm going to draw the circuit again and just so that we can see what's the resistance. يعني نحن عنا هلا here we had this grounded, this had RC here, and at this node we had our circuit, and we had here resistor, and we had another resistor coming from Vsig. This is R3 parallel to R2, and this is R6, and I have a capacitor here, so I grounded the Vsig because of it. and he wants, if we call this Cx, what is the total resistance seen by this Cx? And in this scenario, the total resistance is looking up and looking down. Looking up طلعناها نحن قبل. We said we're looking up through this with the G. RO is infinite, and the beta infinite بيطلع عنا 1 over Gn, if I recall properly. And here, since the base current is also infinite, it's a basic BJT, which is grounded, looking down. So this will be almost like this, looking down. So I will see little RO. Okay, so it will be RO parallel to 1 over Gn. Okay, so it will be RO parallel to 1 over Gn. And RO is infinite, I think. So it will be 1 over Gn, right? But RO is infinite for both transistors, so it will be 1 over Gn. Okay? حدا عنده سؤال? Anybody has any question? Okay. طيب. هلا the last question that we have here is as follows. Using OCTC, find the 3 dB frequency for this amplifier. So we need to come back here and see, well, I have really, let us see how many capacitors we have. حنشيل هيدي CMU2, حنحطها on this side. So it was between here and here. It's really between this node and the ground, right? So this is CMU2. C pi plus 2C mu are treated as one capacitor. Cx, which we just found, is one capacitor, and C mu2 is another capacitor. Okay, so from this side, what is the resistance seen by, يعني حنرجع نرسم هالرسمة تنحلل لل C pi. عندي هيدا grounded وعنده resistance here, and then my transistor is like this, and this is the output. Here I have R3 parallel to R2, right? And I had R sig and V sig, and I have the transistor, the effective capacitance here, which is C pi 1 plus C mu 2C mu1 طلع عنا هون صح من ورا الميلر. So this was 5 femtofarad, and this 5 picofarad, this 5 picofarad. What resistance does it see? هيدا شو بشوف هون ال I0 لأن البيتا tend to infinity. So R اللي حيشوفه هيدا is equal to R3 parallel ل R2 parallel رح نعمل shorting للسيجنال parallel ل R6. Okay, so هيدي صارت associated with this, وهيدا CX صار associated with 1 على GN. بيبقى عندي مين؟ بيبقى عندي the last capacitance, which is sitting at the upper BJT. هيدي is grounded. هيدا is also connected here لهيدا resistance وهيدي وهي إلنا. Here I have at this node I have RC, and then I have here the other capacitor, which is C mu2. Okay, and now C mu2 هيدي I'm gonna short this the signal. The current here equals to 0, so this is really not significant for me. It's as if this node is grounded. Okay, so what the effective circuit is really looking down two BJTs whose bases are grounded, okay, and looking up to RC. Okay, هيدا cascode, and this is C mu2, but this is a cascode with RO tending to infinity. شو حيصير فيه هيدا؟ شو بشوف هيدا الكاباسيتور؟
ماشي.
ماشي, it is just going to see. لا عنده RC فوق. حيطلع up
RCA أنا
yes, so it will see open circuit down and it will see the RC up, right? Let's see the circuit. Yes, it will see the RC looking up, and then we can calculate from this the effective time constant and eventually calculate the يعني نطلع التاو for the 3 terms and then 1 over summation للتاو ونطلع منها 3 dB frequency. Okay. طيب, it is a dense exam, but I just meant to share with you the يعني some problem solving. I'm sure some of you have already gone through this, بس إنه do practice those previous midterms لأنه it makes you more comfortable also for the final exam, not only the midterm.